Evaluate the integral x cubed exponential 2x dx. So you can see the inner function of an exponential function, the derivative of the inner function is a constant. So you use integration by parts, saying that they are a product of two functions, isn't it? Are we together? So if the derivative of the inner function is not a constant, then it is not integration by parts. Okay? So this is a product of two functions. You let x to be u and exponential 2x dx to be dv. You only let u what is easier to be differentiated, okay?
Yes.
Because u will be differentiated. So start. So here we have u is equals to
X
cubed. If you differentiate u with respect to x, you get 3x squared, isn't it? Then 3x squared, then dx. Because du over dx is 3x squared, then you take dx the other side, isn't it?
Yes.
Are we together? Then what is dv? dv is exponential 2x dx, isn't it? For you to get v, you introduce integral on both sides, isn't it? So if you integrate dv, you remain with, if you integrate exponential 2x, exponential function remains the way it is, then you divide by the constant of the inner function, which is 2, isn't it? Are we together there?
Yes.
So you now come back, you know if you have the integral of u dv, you're supposed to get uv minus integral of v du. Then start substituting. What is your uv? U times v. U is x cubed, v is 1 over 2 exponential 2x, isn't it?
Yes.
If you multiply them, you get, first of all, give me u dv, the original problem, which is x cubed exponential 2x to be equals to uv. So multiply u times v, you get a half x cubed exponential 2x. Then minus integral of v du. What is v? V is a half exponential 2x. Then du is 3x squared dx. Are we together?
Yes.
So a half times 3 is 3 over.
3 over 2.
So you see you have your integral here, then v du is this, so a half times 3 over 2, you put 3 over 2 outside, isn't it? Then here you remain with x squared exponential 2x dx, isn't it?
Yes.
So where is our integral? Here. This is still integration by parts, isn't it? Because it is still a product of two functions. So you bracket what you want to integrate. You bracket what you want to integrate, because what is outside is going to affect everything inside, okay?
Yes.
Are we together there? So start again. What is your u now? Your u, then your du, dv. Good. So start again. So u is equals to x. So if you differentiate u, if you differentiate x squared, you get 2x, then you take dx the other side, isn't it? Then what is your dv? It's exponential 2x dx, isn't it?
Yes.
Exponential 2x dx. So v is, if you integrate, you introduce integral on both sides, isn't it? If you integrate exponential, it remains the way it is, then you divide by the constant of the inner function, isn't it?
Yes.
The derivative of the inner function must be a constant according to algebraic substitution. So start substituting. So here you go on with the normal process. You have a half x cubed exponential 2x minus 3 over 2. Then inside this bracket, we have u dv. And what is u dv? uv, isn't it? And uv is x squared times v is u times v. It is a half x squared exponential 2x, isn't it? A half x squared exponential 2x. Then it is minus v du, minus integral of v du. What is v times du? V is this times du, meaning exponential 2x over 2 times 2x dx. 2 will cancel with 2, isn't it?
Yes.
You remain with x exponential 2x
dx.
X exponential 2x dx inside that bracket, isn't it? So you open this big bracket by what is outside, multiply everything inside. So can you open that big bracket? We have You have 3 over 2 times 1 over 2, which is negative 3 over 4 x squared exponential 2x. Then here we have 1, isn't it? Negative 3 over 2 times negative 1, you get positive 3 over 2. This is negative 3 over 2 times negative 1, you get positive 3 over 2, isn't it? Good. Then integral of x exponential 2x dx. So we are done with that. We've opened that bracket. So what are we now integrating? We are integrating this, isn't it? You bracket what you are integrating. What you are integrating is what you are bracketing. Then after integration, you open the bracket, isn't it? So from there, start. It is still integration by parts, isn't it?
Yes.
So that is x is u, then exponential 2x dx is dv, isn't it?
Yes.
So u is equals to x, go on. So if you differentiate u with respect to x, you get 1, meaning du is equals to dx, isn't it?
Yes.
Then your dv here is exponential 2x dx, isn't it? So for you to get v, you introduce integral on both sides. You get v to be, if you integrate exponential function into the way it is, then you divide by the constant of the inner function, isn't it?
Yes.
Are we together? So go on. This one is equals to, you are going on with your steps. So you see, these are the ones to do them aside so that they don't interfere with the step, isn't it?
Yes.
Okay? I go on. So we have a half
x cubed
exponential 2x minus
3 over 4 x squared
x squared exponential 2x then plus 3 over 2 in bracket is integration by parts, isn't it? If you have uv, if you have integral of uv, what do you get? If you have integral of udv, what do you get? uv minus integral of vdu, isn't it? So what is uv? U times v. U is x, v is a half exponential x, isn't it? If you multiply, then you get a half x exponential 2 x. Then it is minus integral of vdu, isn't it? Minus, what is integral of vdu? V is over x, then du is just dx, isn't it? So you take 1 over 2 outside, then you get the integral of exponential 2x d. Yes. Are we together there? Okay? So from there, what do? You open the bracket, isn't it? Open the bracket. So if you open that bracket, what do you get? Here we have a half x cubed exponential 2x minus 3 over 4x squared exponential 2x then plus 3 over 2 times you get plus 3 over 4x exponential 2x plus 3 over 2 times negative a half negative 3 over 4 then inside you now then integral of exponential 2x dx, isn't it? So you see, this is no longer integration by parts, isn't it? That is now an integral of an exponential function alone, isn't it?
Yes.
So you now put bracket where you want to integrate. That is what you want to integrate. So if you integrate exponential 2x dx, what do you get? So we are now going to have a half x cubed exponential 2x minus 3 over 4
x squared
exponential 2x plus
3 over 4
x exponential 2x minus 3 over 4 into, if you integrate this, you get exponential 2x, then you divide by the derivative of the inner function, which must be a constant, isn't it?
Yes.
Plus c, and you are done with the whole integration process. So if you like, you are done there. You don't even need to open that bracket, or you open if you want, isn't it?
yes
Good. So that is how to deal with such case. That is how to deal with such a case.